Hello, everybody. We're going to look at HashCat. It's a well-known password cracker. It tries to crack a password by taking the hash, converting it into plain text, and then comparing that. No, sorry, it takes the plain text words, converts it into a hash, and then compares hashes together. So hashes turn readable data into a garbled state. It's a random string of fifth lengths. Remember we looked at that? That a hash, like an SHA 256, is always the same length, no matter how long the information is that you have into it. So HashCat uses pre-computed dictionaries, rainbow tables, and even a brute force approach. So let's take a quick look at what this looks like. So here's my password, and we'll just say this is the hash of it. Well, you can't reverse the hash. But what you can do is have a dictionary of common passwords that were taken from a dictionary, from a hack. And then what you can do is take each of these, convert it into its hash, and then you can compare the two hashes together. When those two hashes are the same, you know you found the password. Well, that takes computing power. So when it says HashCat uses pre-computed dictionaries, that means it's a dictionary that already has the hashes in there. Creating a hash takes a certain amount of computing power to do the conversion as you go, although it doesn't take very much time. So we aren't comparing passwords. We have a dictionary where it has the whatever the letter is, whatever the password is, and a pre-computed hash. And once we match hashes, we know that's the password. Hashes are what gets passed across the network when you authenticate with almost everything you authenticate with. Turn on your phone in the morning, turn on your TV, go into Netflix. Hashes get passed because you can't reverse the hash. And since everything's encrypted anymore, first you have to break the encryption of the TLS encryption, transport layer security, which is, we still call it SSL, but SSL hasn't been used for several years. We use TLS now. 1.2 and 1.3 are the current standards. So for instance, I tightened up my web server after I ran the test that we did this last week on my web server in the back of the room. I discovered, oh, I better do something because I got a B- or something on my website. Well, that's because I didn't have things set up right. So I went in and set things up right. So, oh, look at we got better air quality today. Last couple of days were not good. Let's see, what is it called? SSL checker. So we did that last week. SL, no, that's falsys. So this is the domain of this one. When I ran it the first time, I thought, well, I should be running this against my own stuff. It did not come up very pleasant. I had all kinds of old things turned on by default, so I fixed it. All right. So we're going to use the HashCat package, and here it shows what happens. Here is my password, right? It gets hashed up into this real wiggly stuff. Collision. Collision would mean if the algorithm does not compute a unique hash for each word. So they're using the example of let me in and Superman just as an example, that they end up with the same one. That happens very rarely in newer approaches. There is no 100% way to prevent dictionary attacks or brute force attacks. If somebody can capture your hash of authentication, they can sit there for the rest of their lives and try to figure it out. However, if you change your passwords on a regular basis, what does that mean?
It's always changing.
The hash is always changing, yeah. And so that's why it's a good idea to have change your passwords every so often. But we have encryption, then we have hashes going on. So we have they have to get past the encryption first to even get to the hash. So that slows things down because almost anything we do, including communication between here and my file servers, that's all encrypted. Almost everything's encrypted. My website, buildthecomputerguy.com, was one of the last unencrypted websites, and now I have it encrypted, although there's nothing on there that I care about. All right. So we're going to, yeah, multi-threaded means it can do more than one thing at a time. It works in all kinds of stuff. Okay. We're going to crack it. We're going to create a shell script with Nano. Why would we create a shell script? Well, who wants to type in all this one line at a time? Not me. No, no, no. Oh, and I use Shift Insert in here. I should have used Control Shift. Right? Because I think that's easier to remember. BRL, SHIFT, Control Shift P. Because Control P is paste in Windows.
That was B.
Yeah, it's V.
Oh, thank you. You're right, it was V.
It's like, they changed that.
Because P is print, isn't it?
Yeah.
Okay. Well, this would be Control C here. Anyway, I'm going to slide this out of the way so we make a little shell script, which is something we should know about. So oh, there we go. Oh, I don't have my power settings set right because now it's locking me out. But I'll fix that another day. It's in the directions. I just didn't do it here. So Nano is a good way to create a quick shell script. And if you type in the name of the program, if it's a text editor, and then type in the name of the file, it'll create that file and open it up in the program at the same time. So we're going to do create hash dot sh. sh is the standard extension used for shell scripts in Linux. Does Linux care about extensions?
Very much so.
No, Windows does. Linux recognizes what kind of file it is by the type of file it is. sh is for us so we can remember it's a shell script.
Okay.
That's what the sh is for. And we're going to copy the commands below. You could type it all in if you wanted, but I'm going to drag my mouse through it and copy it and paste it. Now Control Shift V. Ooh, much easier, isn't it? So I'm going to put in one of my password 01 is already in here. So whenever it says insert one of your passwords, put in one of your passwords. And what should I put in? No, Husker's is already in here, isn't it? What's another dumb password that people use? Oh, here's one. They just go across the top of the keyboard. So now we have it. We'll save it. This is going to print to the console. That's what echo does. And I think -n means don't show on the screen or something like that. I can't remember. This is the text we're printing to the console. We are sending it to this program, which is in Linux. And I don't remember what these do, but what it does is it creates a new line. That's probably what that does. It's going to create a hash of this, insert it into here, and keep adding things until we get to the end, and we'll end up with this many hashes. Well, let's exit. Now, sorry, Control S to save, Control X to exit. I did it without thinking about it. Sorry about that. I've used this enough times. So it doesn't show Control S down here, but Control S does work. If you use the write out command, that means write it to file. If you do Control O, then you press enter to write it to a file. So that's kind of like save as. When you see the little upward pointing caret, that means use the Control key. So press enter, it says, yep, there we are. Control X to exit. Whenever we want to elevate to the root level temporarily to do something with our system, we do sudo, and we're going to change the permissions of our file. We're going to make it executable. Actually, we don't have to do 744. We could just add X to it, but we'll do it the way it's in the. And if I type in a few characters of my file I'm working with, I can press tab, which is called tab completion. And then I don't have to type in the whole file name. it's very easy to make a mistake typing in a file name, but tab completion works in Kali Linux. It works in Windows. It works in Raspberry Pis. But you have to have enough of the file name to be unique from everything else in there. So we press enter. We have to put in our secret sudo password, ls-l. And notice that create hash.sh is now green. And it has an X here. That means it's executable, where our Python file is not executable. D means it's a directory, and that's something different than what we're dealing with. We are just looking at files. So that means that create hash.sh can be run without, okay, that says what happens. We did that, wow, I have these directions in here twice. Why did I do that? Okay, somebody's gonna have to look at his directions. Because now I'm doing it twice, aren't I? Yep, I'll fix that. So if you do // that means in the current folder. I know that's not terribly intuitive. You don't have to do that. You can type in CREA and then tab. Oh, it's not going to do that, is it? /C. And there it is, create hash. I need a little bit more to be unique. There. Now I got it. And it runs. It's an executable file. If we hadn't made it an executable file, we could type in bash ahead of it. Bash is the command line interpreter. And then we could have done create hash. And there we go. It would have done the same thing, but then you wouldn't know how to make an executable script. So adding the X to it means that it's executable and you don't need this. Well, let's see what's in there. There's our target hashes. Shall we take a look at those? Yes. The cat command is short for concatenate. What it does is it allows us to quickly look at what's inside a text file. All configurations in Linux are text files. There it is. So who can get out their calculator or their pencil and paper and reverse that to our original passwords? Nobody. But that's what all the hashes look like. Notice they're all the same length, but they're all unique. There's a couple that start out with 65E, but then after that, it's all scrambly goop. So now we have our hashes one at a time in the line, and we can go through and see if we can figure out what those hashes would turn into by using a dictionary called ROCU. So we're going to use the LOCATE command. ROCU is like one of the really oldest password files that's from when people hack in and get, these are all from password dumps. And there it is. It's underneath USR share word list /rocu.text.gz. What do you suppose GZ is about? We know what .text means. GZ is a compressed file. GZ is like a zip file for Linux. I think it's gzip. Oh yeah, it's gzip. So we're going to copy that to our local folder so we can extract it and use it. So USR, SH for share, WOR for word lists, and then ROCK, and there we have the whole thing. CP means we're going to make a copy of that, and we're going to copy it to our home/user. So we have a copy in this folder we can uncompress and work with. There, it's a pretty big file. It'll be even bigger when we uncompress it. Sudo gzip, that's the gzip program. gzip program. -D means decompress, probably. And there's our file, rocku.txt.gz. And that may take a moment, but that's a big file. And look at that Hummer. That's a big one. It's a text file, but it's lots of passwords in it. So if we use the, oh, what is the command? It's not top. Can't remember what it is. There's a command where we can just look at the head. Head gives you the first 10 characters. So it gives you an idea of what's in the file without having to do cat for the whole thing, because it's probably like 1,000,000 lines long. But you can see the type of things that are in there. These are all passwords that were on a password dump that were hacked from systems. And these are passwords that people actually have used. Oh, that's what I was thinking of, more. More allows us to page through. There. So every time we hit a key, we page through. And yes, there are bad words in here because some people use bad words, swear words. Control C or Q will quit. Now are we ready to crack? You're thinking you're ready to crack. Anyway, a HashCat -H. Oh. Well, that changed apparently. Bad option. Okay. If you look here, there's this whole big giant stuff here. So you have to have 3 GB of RAM to run HashCat. If we were on a physical machine, the GPU would do all the work. And I know I don't have mine at 372. So to do this, I'm going to have to shut down my Kali Linux and change the memory. You can do that from the command line on any Linux distribution with sudo power off. That shuts down the operating system nicely, and it's a short way to shut down a computer. I think on the interactive in the GUI, you just have to type power off. Yep, there it goes. So we need our manager back. We right click, settings, and system, there we are, 3096, 096. That gives us 3 GB of RAM. If your machine doesn't have at least 8 GB of RAM, this is not going to work very well for you. I don't think I need a floppy disk in there, do I? Still have floppy disks showing up in our virtual machines. All right, we started out again. Now we can run this big long honking command. Which is why I have it in the document so that you can copy and paste it. Let's pause. All right, now we have 3 GB. If I type in the top command, that gives me just kind of the basic stuff about my computer. I have 3 GB total. I have this much free. I have this much used. This shows all the processes. This is a like quick system information. It's kind of like your task manager in Windows, but this is for Linux. So it says how many CPUs, which you only have 1, or, you know. Q will quit quite often, little programs like that take over your screen. If Q doesn't quit it, you can do Control C. Control C will break most command line programs in Windows or Linux. Now, this guy is 2 lines just because I couldn't fit it into 1 line. And if I did like make it small enough to fit in 1 line, well, then it would look silly. But maybe I need to do that when I revise this, because obviously I have some problems with it. So I copied it. And when I go over here to paste it, see it wraps around to the 2nd line, but it all has to be 1 line. So HashCat is going to put the passwords into this file. These are the target hashes. it's going to make hashes out of all the passwords in rocku.txt. And this is going to force it, I think it's this one that forces it to do the GPU, or this one does it. One of these two says, I don't care if there's not a GPU, just go ahead and do it anyway. Okay, so force. So yeah, it gives you all kinds of warnings and it's got a, tells you all kinds of stuff. And it could take a while. And I think it does come up with a couple of them. Yeah, I don't know. I don't think we're gonna have a watchdog temperature happen at 90 Celsius, but because we're on a virtual machine. But this can take a bit, so we're gonna pause and do something else while it's working. So how long it takes depends on your local computer. All right, we do ls, and we have crack.txt. We'll concatenate crack.txt. And look at there. Didn't get all of them, but it got some of the dumb ones. Like even it got QWERTY, password, hello, password with ats and zeros and huskers and even P455, P455. I have no idea why that's in there or why that's a cool password. That didn't take long, did it? On a physical machine, this would go a lot faster. Well, we're successful. Now, if you put one of your passwords in here and run this, it shouldn't show up as an answer. If it does, then you probably should change your password. I did not put in one of my passwords here because I'm recording this for everybody else to see. But all the password cracking that goes on in this stays on your virtual machine. So you won't be like giving anything up to try one of your passwords and see if HashCat can crack it. And rocku.txt is pretty old. So if you have a password that's in there, you darn better change it pretty quick. The odds are very good it's not going to find your password. There it is. HashCat is actually used, that and John the Ripper is another version of HashCat that's used to crack passwords. And Owen and I have been watching Mr. Robot, and guess what operating system they use in Mr. Robot whenever they have a Linux thing come up? What operating system are they using, Owen?
Linux.
Kali Linux, yeah. You see the little splash screen of Kali Linux. Yep, so they have Rugger Duckies, Kali Linux, social engineering. Yep.